Welcome to another week in astronomy. Not necessarily the biggest news, but the things that caught my eye. Just one thing this week, a NASA study called The Value of Near Real-Time Earth Observations for Improved Flood Disaster Response by Oddo and John Bolten, published in the journal Frontiers in Environmental Science. It's a very interesting paper in my opinion, so I want to give it enough time to talk about it in fairly decent detail, and I'll put a link to the article in the description. So, what's it about? I'll start by quoting from the abstract. They say, data regarding the geographic extent, severity and socio-economic impact of a disaster event can help guide emergency responders and relief operations, particularly when delivered within hours of data acquisition. Okay, so they set out the problem like that. It's useful to have data on the geography of your disaster if you want to know how to help, how to respond to it. They go on to say, information from remote observations provide a valuable tool for assessing conditions on the ground more quickly and efficiently. Okay, again, setting out the problem and the idea that remote observations, i.e. in this case satellite-based observations, can be very useful. So, they get to the point. Here we evaluate the social value of a near real-time flood impact system using a disaster response case study and quantify the value of information, VOI, of the satellite-based observations for a rapid response using a hypothetical flooding disaster in Bangkok, Thailand. So before I go on a quick explanation of the term, in economics, value of information is the amount of money that a rational agent would be willing to pay for new information before making a decision. And you can sort of extend this idea for disaster relief to get a rough value of how much you're worth, or how much your idea is worth. So what do the authors do? They firstly use data based on the 2011 floods in Southeast Asia, focusing on that area and getting an idea of where was covered with water, what's the depth of that water, as well as where dispatch points for emergency services and population sites are. What they then did is use NASA's NRT, or Near Real-Time Flood Mapping, to get an idea of what data the emergency services could have had from satellites. They used a piece of software called Open Route Service, ORS, which is a navigation service, an open source vehicle routing software, which allows you to find ideal routes from an origin to an endpoint. And what makes this useful for them is it has a feature where a user can specify an area to avoid by using a polygon to cover that point. So, of course, that means you can cover the places you know are flooded with polygons and then get a route which avoids them. They choose to assume that in this scenario, they say, we assume the vehicles have been given some advance warning of potentially adverse road conditions and choose to circumvent the most highly impacted regions. Okay, so this lays out how they can test the impact of their satellite data. They used coordinate locations from 10 dispatch centres and 75 population sites, or places where they want the emergency services to get. That gives them a total of 750 routes, which they first put into ORS to get their baseline routes. Some gave no valid route though, so they ended up with 518 routes where they could find a valid route between these 2 points. They then found the alternate routes with flooded areas blocked using near real-time data. As I said before, blocking off places where there was heavy flooding and getting the software to calculate an alternate route. They could then compare these 2 information sets for the amount of impacted route to clear route, so an estimate of how often you're travelling through flooded areas, as well as the expected response time which they attempt to calculate. So they can work out how much faster they expect the emergency services to get to the places they need to if they had access to data on which flooded areas were blocked off. Finally, they referred to an earlier piece of work which looked at the economic value per minute of emergency response time based on fatalities and severe injuries for the Thai emergency services, although this is not explicitly for flood data. This allows them to make an estimate of the economic value of the time saving by avoiding flooded roads. The results look good, as they seem to claim about 9 minutes time saving on average for having satellite routed data, which would give them a figure in the millions of dollar range per disaster, as well as making the obvious point of helping people not die. And if you think of this for just one disaster, things start to look really rosy for satellite flood monitoring. However, the paper has an entire section which talks about the caveats that they have with these methods. They're fiendishly hidden from people trying to report on this by being in a section called Caveats and Future Research Needs. I did manage to track them down, so it's worth going through these and understanding that actually the picture isn't quite as rosy as they painted it earlier on. They firstly point out that flood depth estimates are of course subject to error, and this error depends on the surfaces that the flood mapping is being done over. Sometimes you're trying to make an observation of the depth of a flood based on a picture from in orbit. It's not perfect. More important is the point that this ignores the dynamic nature of flooding. Flooded areas change over time. In this case, the near real-time data these satellite maps provide may not be as much of a benefit as they calculate for the static case. It also doesn't account for other sources of traffic. For example, congestion because people are fleeing a disaster, or routes being blocked up even though they're out of floodwater, because if this is associated with storms and high winds, you can get fallen trees, you've also got car crashes, power lines coming down, all that sort of thing. It also massively underestimates how good the route planning without the satellite data is. While this is likely a compromise to allow the comparison in the first place between with and without satellite data, it does lead to overestimating the benefits of their data. In reality, people have phones and radios exist, so word gets around about the worst flooded areas. Also, the emergency services aren't thick. They have common sense, local knowledge, skills of geography. They can avoid areas they think are likely to be flooded due to the lay of the land and what they know, especially if there's been previous disasters in the same area before. They can cover things like this and they can try and reduce the problems. Also, drivers have brains. Despite what my experience trying to travel along the M25 leads me to believe, there are people who can drive a car and still have a reasonable amount of grey matter in their head. And they can change their route in this case in response to the local conditions. They can reroute around impediments. And of course, this means again that the benefit of the satellite data avoiding that problem may be overestimated. So it may not be a millions of dollars disaster saving piece of brilliance, but the paper does make a reasonable case that access to it could be useful, and states clearly its limitations. If you use this as a starting point, say to justify the combination of near real-time satellite data with other emergency service methods, or justify improving our near real-time monitoring activity, I think this will be a useful paper in doing that. As I said, it's only this from me this week because I was hoping to do this justice. I think it's quite an important piece of work to go through in detail rather than flinging through it in a few minutes. So I hope I managed to do that. Goodbye, and I hope to see you next time.